Something. Okay, first things first, I'm supposed to take a selfie with this thing. Let's see how it goes. Do make some noise, please. Oh, come on. Once more? That's chocolate? Yeah, that's slightly better. Let's see what it did. All right, good afternoon. My name is Karl, still. I'm an Azure MVP. I'm a community organizer. I organize Global Azure Bootcamp along with Martin and formerly the other Martin as well. I organize Finland Azure User Group, IglooConf, PolarConf, and so forth. I'm semi-actively tweeting my own bookmarks as links to Twitter, and I'm also speaking along conferences mainly in Europe, mainly about Azure and security. And I've been working with Azure since 2011, mostly as a consultant type of a role. I've seen maybe a couple of hundreds of different Azure environments or applications or implementations, some even good as well. And this following session that we are going to talk about is based on the security experiences, security findings, but specifically related to this Kubernetes thing. But we'll get to that. I come from Azure, just updated the numbers from Sakari. There should be pretty much the same slide in there. Yes, we did just publish a new site in Ghent, Belgium. And that's about it. Okay. What to expect from this session specifically. At the end of the session, you should be able to have some ideas about how to build, operate, and architect web applications securely on top of Kubernetes service on top of Azure. Essentially, you'll see a list of different security controls that are available, pretty much an idea about what does it cost in terms of performance or work for you as a developer, operator? What does it cost to implement those security controls? And what are the benefits so that you can make a conscious decision of leaving everything as it is? And you'll get a ton of resources, links, videos, so forth in the end. Yes, you will get the slides as well. And I hope that you will gain at least some knowledge regardless of your security or Kubernetes expertise so that you have at least a better idea of what those other people are doing on that side of the fence. Now I can move. Okay, but before we go any further, I want to ask a couple of questions about this Kubernetes thing. So please raise your hand if you actually have worked with Kubernetes or have something in production on Kubernetes. Pretty good. Like third, maybe 25% of the people. Very good. So as Tom mentioned earlier and as discussed in the panel as well, it's not really a one-hit wonder. It's not really something that will save the day at all. So before you start thinking that Kubernetes will solve all of my problems, you really should have an idea about if your application is actually even meant to be hosted in the cloud. Is it something that you are able to maybe host on some other platform as a service components, maybe even? Or what are those deprecation or portability requirements that were discussed by Tom's other session or even Sake's session there as well. But I'll do a quick couple of minutes of introduction to some of the key terminologies quickly related to containerization and Kubernetes, just to get us on the same page on these areas. So these are actually slides from the Children's Illustrated Guide to Kubernetes. So this should be manageable for all of us. I said I give you resources. So really quickly, containers are just a fancy way, current way of packaging applications and sending them around, hosting them. But the idea is that our application code, for example, in this case, a fancy PHP application running on some sort of web server, that it needs to be managed somehow. Someone needs to actually download the image. They need to start it up. We need to make sure that there's some CPU, there's some memory, there's some disk available. If it's a PHP application, unfortunately, a lot of them are connected to the internet as well. So there maybe needs to be some sort of networking that we need to think about as well. And if we are maybe even uploading a new version, if there's a revision or a new major release that we are doing, we need to also start planning about this kind of load balancing and scheduling as well. And in Kubernetes world, these containers are actually hosted in something called pods. Pods are just a container of container inside a Kubernetes, essentially way that a package of that application package. And this is the unit of scale that we talk about when we talk about scaling Kubernetes applications or when we spin up new pods. And we'll get to more details where do these pods live very, very soon as well. But essentially, once we have that pod that's hosting our application in a container, we can actually upload that to the world or expose that to the world through something called a service in Kubernetes. And that service is then finally something that actually exposes something that we outside of our Kubernetes environment can actually call to. Most likely in Azure world, it's some sort of a load balancer. It can be an application gateway. It can be just a Azure external load balancer. It's a public IP address in the end. So an application itself, when we talk about a simple application that we want to expose outside and even just load a page, we need to have all of these, the actual container image, the pod, the service, all of those available before we can do anything. And those are all Kubernetes stuff. Those are regardless of where are we hosting that. On the Azure world, anytime we actually spin up a service that will actually start consuming resources as defined in the pod, start uploading or downloading that image of a container, start consuming some memories, downloading something from outside, all of that is actually hosted in a cluster of virtual machine infrastructure that is managed by Microsoft Kubernetes Service, Azure Kubernetes Service. So this means that essentially our application architect over there just tells Kubernetes, please spin up this new service for us, and Azure makes sure that there is actually relevant amount of virtual machine capacity available. If we want a new service, if we want a new load balancer or new public IP address, we are not going to script or start up an ARM template or go to the portal and create one. We just say, please expose this service as a public IP address. And Azure makes sure to do that all for us. The implementation details are there. So essentially, we are working with the Kubernetes tools and Kubernetes APIs, but behind the scenes, this is something that we even see. We can manually work around this as well. This is the infrastructure cluster that Azure Kubernetes Service is creating for us. So there's virtual machines, network security groups, disks, high availability related availability sets, and so forth. So now that we have that aside, we can start talking about securing all of these things. And let's start with this cluster security, this virtual machine, this infrastructure part of Azure Kubernetes Service. What was the trick? Pause, drink. All right, so let's start talking about how do we access the management pane. So how does the Azure architect, or how do we access this Azure Kubernetes service from Azure role-based access control point of view? So to provision all of those virtual machines, Azure actually needs to store somewhere some credentials that are actually high enough, to have power enough, are powerful enough that they can actually create those virtual machines. So they essentially need to have maybe a contributor level access to that environment where they will be creating the disks, deleting the disks as needed, creating new network-related items on Azure resource groups, and maybe even changing existing, connecting to an existing network as well. So we need to have some sort of entity or some sort of identity in Azure. Most likely it's a service principal in Azure AD that we will create, we will assign some role-based access control privileges. And that identity we then need to store and grant Azure Kubernetes Service to use on our behalf. When we say, please spin up a new service, Azure Kubernetes Service will create a Kubernetes service or that application using the credentials we have saved there. And we also need a way of contacting that container registry. Don't do what we presenters do, don't do what Martin did just earlier, that showed to the live stream the credentials, the master key of accessing to the container registry. I took a picture. Because then the only thing you need to know is the name of the registry, name of the repo, which is quite public, right? And then just the master key, just like with storage accounts, account key or the master key. So instead of that, let's do it right. So let's use the service principal, so Azure AD credentials again. Those technically could be the same, of course, but well, let's just keep these as separate roles for those service principals. So we need access to create new resources on Azure for that cluster, and we need access to authenticate against that container registry where our Docker images or container images where our application is in order to download those as needed when we create new servers, then we download new images from that container registry. And then most likely, hopefully, this is something that we'll talk about very soon as well, we'll also have a way of authenticating the users who are actually logging in, authenticating inside the cluster, actually saying, please raise up this service, please create new application, please do this scaling operation. For that, we either need to create manual users in those virtual machines inside those Kubernetes cluster infrastructure, or we could use Azure AD to do that as well. So we end up having to need 4 different service principals to register on Azure on that side, and granting appropriate access there as well. So really, Azure Kubernetes Service can and should be configured to use Azure AD for authenticating those users who are logging into the cluster, those Kubernetes operators or SysDevOps, pick a name, pick a role, essentially those people who are operating the applications inside the Kubernetes cluster. And to do that, here's an example of when this is set up. Essentially, the experience is still the same. I still use AKS get credentials to actually try and connect with my Azure AD credentials. It connects to that, logs into Azure. It tries to pull the Kubernetes cluster user credentials from, in this case, Karl AKS cluster. We try to do it. We actually get the connection details. We save those locally in the kube control. But when we actually start to use kube control, so this Kubernetes tool for actually managing those pods and nodes and everything, we actually get prompted to log in, just like as Martin was prompted to log in using this, was it a Jupyter notebook inside essentially, whenever we are doing something that doesn't provide modern authentication capability, when it's not a machine where we are doing it locally, we get this option of logging in maybe with our phone. We just have that URL and that code. We can do that login safely in a trusted machine, and we can continue from there. So essentially, once I finally run the kube control get pods, I actually can go ahead and navigate to Microsoft.com device login, and after I log in with my Azure AD credentials, I get prompted for that particular code, as you'll see the CS9 something there as well. And boom, after that, in this case, I was using the Azure Kubernetes Service Azure AD client service principal that I created. That is the identity that I had to previously configure to be able to log into as well. So this is for users. After that, I have trusted identity provider for users in my Kubernetes cluster, which means that that's nice, but what can they do? By default, they can do anything. So everything. So we need to set up also inside the Kubernetes cluster Kubernetes' own role-based access control as well, so that maybe not everybody in the cluster can do everything. And there's tons of resources, not Azure-specific, but Kubernetes-specific resources on that. But there's also this nice little thing that I can actually run this AZ/AKS get credentials also with this nice extra flag, admin. And what does that do? Actually, when we drill deeper, this is actually two different ARM operations. One is getting the user credentials for the cluster, one is getting the admin credentials for the cluster. And quite unfortunately, if I run this with the admin flag again, I again get those credentials or get those connection strings. And when I run the kubectl get nodes, almost misspoke there, you'll see that I'm not getting prompted to any Azure AD logging. Within the same cluster, I'm skipping all of that. So if you allow in your Azure environment, if you give your Azure Kubernetes operators contributor access to that Azure Kubernetes service, or any access that allows also these admin credentials, you are also allowing them essentially skipping that Azure AD authentication. Even if they're admins and they want to have a role in Azure called admin, you shouldn't do that. You're skipping the whole point of centralized identity management. And then there's even AZ/AKS get credentials /x, which skips, again, everything. Okay, so how can I prevent this? Essentially, on the Azure activity log, we actually see this. This is the call that we can make, or we are making when we are doing the AZ/AKS get credentials /admin. We are actually calling Azure Kubernetes Service Resource Provider under managed clusters list cluster admin credentials. This is something that we should at least monitor and audit for, but preferably maybe even block our users of doing altogether. And the appropriate Azure resource provider actions will be the list user admin credentials. And there are built-in Azure role-based access control roles that differentiate between these two different actions. So we are finally inside the cluster. We have logged in. We have logged in using Azure AD. We have appropriate things to do. Now we can finally implement proper access control in there. And I mentioned there's something called Kubernetes role-based access control, which is different from Azure role-based access control. So inside the Kubernetes role-based access control, mouthful indeed. Inside that, we have options of building our own roles, just like with Azure AD. Azure role-based access control, we can actually build a list of allowed and not allowed options, and we can assign those roles per sets of namespaces or per sets of nodes, which are the virtual machines inside the cluster. And we can even define these pod security policies, which define that this set of pod is actually usable or editable by only this type of role. And once we have that access control all kind of in place, everything is nice. We are doing everything by the book. We are doing giving roles that are only usable per the kind of need to know and need to do basis, we can actually start thinking about operating the AKS cluster more. And I really want to point out a couple of things related to operating these Kubernetes service clusters. Even though AKS has been called by some platform as a service or Kubernetes even as a service, even as the name would suggest, there are still some things that we need to do. And I really can't stress this enough. So Azure does automatically apply those security patches to those nodes, so those virtual machines that are sitting in our Kubernetes cluster. That's fine. Yes, Azure does it. Every night they go ahead and download all of the patches. But we are actually responsible of ensuring that those virtual machines are actually rebooted, or if there's some applications that need some extra configuration after those patches. And yeah, so we are really responsible of updating or making sure that those nodes, those virtual machines are actually updated. We can automatically schedule this if needed. We can have a person whose job is to reboot the servers every day, as we've had. But really the point here is that Azure Kubernetes Service is not platform as a service in a sense that it's evergreen. Once you're done with your project, you can just leave as it is. There is constant operational responsibilities that you are having to budget in for the project for. And another thing here. So Azure Kubernetes Service is actually free, right? We are only paying for those virtual machines that are getting created. We are actually not paying for the master part of the cluster. We are only paying for the slaves or the nodes of the cluster where our pods are actually running. So there's nothing to actually, if the Kubernetes service is down, Microsoft cannot pay you anything back because you haven't paid them anything for it, right? And that's the reason why, or the official reason why AKS has no SLA. They have these targets, but they have no SLA at all. So they seek to maintain an availability of at least 2.5 nines of availability for that master server. So if you want to say, please install a new version of my application, please go ahead and download the new container image from our registry. That's an operation that needs to go through that Kubernetes API server, and the target, not even guaranteed, but the target for that availability is 2.5 nines. So if it works, nice, but it doesn't have to. There is official support. AKS is, of course, a GA'd product, so there is, of course, official support from Microsoft, but there's no SLA. And yeah, so another thing related to the operations as well, there is a UI, there is a dashboard that you can use. You won't be someone like an anonymous Californian-based car maker who just leaves their Kubernetes dashboards open to the internet, right? Better yet, you should really disable it if possible. By default, right now in Azure, it's actually always there, even if you don't use it. But there is a feature coming in the backlog that you are able to limit who is actually able to call that. Maybe only IPI, or only network from your own Azure environment, or maybe only your internal network can access that dashboard, or any other parts of your Kubernetes API of that master. And that's a nice way of going to the next part, which is security, network security. Okay, very basic application, some sort of web app. It can even be that index or PHP application over there that's sitting nicely in our Kubernetes cluster. Very simplified. There's some users that need to access it. Apparently they have very big phones and very small or very light laptops, but they need to access that web application that's sitting inside that Kubernetes cluster. And then we also have those admins that need to access that Kubernetes cluster to perform those operations that we talked about. They log in using Azure AD, they have some Kubernetes RBAC roles in there, they upload or they orchestrate, they tell the Kubernetes service to download a new image and so forth. And then the Kubernetes service or the cluster or the application inside that Kubernetes service actually needs to access some external services as well. Maybe Azure SQL database, maybe something totally third party. So how do we secure all of this from the network point of view? So it was a simple picture. So what we need to do is really restrict the access to those, in the end, to those virtual machines. Again, it's just infrastructure, it's just IaaS, it's automated, it's more easily accessible, it's controllable from within the Kubernetes service. I don't need to learn ARM, I don't need to really learn about Azure if I'm very proficient on Kubernetes to implement this. So I can say that, okay, for this access to my web application, is this something that I want to publish as a load balancer from Azure? Is this something that I maybe add an Ingress controller from our, maybe one of our pods is actually an Ingress controller, maybe there's like Nginx loaded there, maybe there's Azure Application Gateway or something else that I want to use. But essentially from my service, if you recall, my container image is in a pod, which is in a service, and that service level defines where is this application or this service, where is this exposed to? Is this exposed to only to the cluster? Is this exposed also outside as well? So behind the scenes, when I run this or when I install this service in Kubernetes service, then Azure will actually use those service principal credentials that have access to create a new rule in a load balancer in that infrastructure that they are managing for us. And again, the same thing for admin access. If there is some admin tooling, they're available inside the app as well. Then those same virtual machines are actually sitting inside a virtual network, which we can go ahead and manage on our own. We can define a pre-existing virtual network, which means that we can define our own network security group rules, which means that we can say things like, yes, allow access from this particular private endpoint of a SQL database, or do not allow access from all the world, maybe just our virtual networks, for example. And we can open those service endpoints, private endpoints to those platform as a service components as well. And yeah, inside of all of this, we then have these more configuration that we can do. Essentially, when we have a public IP address that's exposed by an Azure load balancer, we can actually tie that to a web application firewall, a managed Apache mod Spark that's a feature of App Gateway. And we can set up SSL termination, we can set up OWASP top 10 rule sets, maybe even turn on the firewall, which isn't there by default. By default, it's just scanning. Maybe it's useful to just actually configure it in a way that is even preventing all of those known web exploit attacks and so forth. So once we have that service exposed in the cluster, it becomes a regular old IP address in Azure VNet, which means that we can add WAF, we can add DDoS protection, we can do all of that. And there's also a feature coming that instead of first exposing this whole thing, the service as a load balancer, and then tying that load balancer to a WAF, we will be able to actually define the whole Ingress controller as a service in Azure, that it's not just creating a new IP address, that is actually creating also the application gateway, the WAF, automatically from just a Kubernetes command as well. Okay, so let's move on to those actual applications. We'll talk about accessing the cluster and how does the cluster get created and how does the cluster access anything. And we talk about the network access. And now we have that application, that beautiful PHP application sitting inside the Kubernetes service, accessing SQL data securely. And now we can start thinking about what to do with it. And we had those policies, I mentioned those pod security policies, so which user can access what. But even inside the cluster, connection between those pods, between the applications, is sometimes quite meaningful to control as well. If you have a front-end application, can they directly modify some sort of message queue, for example? Do they have access only to some parts of that, some applications inside the cluster? So essentially, we can define this pod network policy, which allows us to say this backend is or is not allowed to connect to this front end and vice versa. So we can control the flow of this incoming traffic and outgoing traffic even inside the cluster, even if we are actually, all of those pods will be inside the same node, inside the same virtual machine. Because they are not talking directly to each other, they are not even talking through Docker network layer, they're actually going through the load balancer of the cluster, so Kubernetes network layer. So there's 2 or 3 abstractions even before we start talking about this Azure virtual network. So in the end, essentially this is just a nice YAML that you can use that creates this list of essentially IglooConf rules inside each of those nodes, essentially. It's just dirty work for us, done for us. IP table rules, sorry. And we can go even further. So if you've ever heard of Azure Managed Service Identity or Managed Identity for Azure Resources, we don't even need to care about the network part. We can just define that this pod will have a managed identity. It will have an identity on Azure AD, which means that we can give them access. They don't need to authenticate themselves. They don't need to store a connection string to that SQL database, for example. We can just say, define that in the SQL database, define that as an allowed user to read this particular row or table. We can say that, yes, this pod has access to that Kubernetes, Azure Key Vault to get new certificates to download. You're a new pod, we haven't configured you, how do you get the certificate to connect to that WAF? Well, you need to get it from somewhere secure, right? So Azure AD Pod Identity is a way of creating those managed identities as we would create function app or app service managed identities as well. So essentially, if you follow, for example, fellow MVP and colleague Jonas Westlin, he has a nice example in his blog and in his GitHub about how to assign managed identities as users and how to configure SQL database access with his SQL scripts for managed identities. And this is an example essentially, once we configured this managed identity from external provider. This pod 1 is my application that needs to connect to SQL database. It's something called pod 1 in Azure AD as well, so we can just create a user inside that SQL from that linked Azure AD, and then we can grant select on that database test for that user or that pod identity. And then inside my pod, in my code, I can just, instead of defining the whole SQL connection string, I can then just say, just go ahead and connect to it. This is my connection string, just the name and the server, database name and the server address, and that's it. And the best part is that I can track centrally from Azure AD logs that which of these identities are being used and how. There's also a way of automatically mounting Azure Key Vault secrets search any resources inside Azure Key Vault into Kubernetes accessible variables, essentially. Instead of configuring an environment variable inside your Docker image, which is obviously not super secure if you share your container registry keys everywhere, you should get those keys at runtime, right? And how do you get it? You need to, first of all, identify yourself who you are, can you even get those keys, and then download or fetch those keys from a centralized key storage, from a key vault of sorts, and yeah, get those and mount those at runtime as environment variables for your pod. Okay. We talk about the cluster security. So how does the cluster actually have access to, or the AKS resource has access to create new resources on Azure? We talk about how to connect to it. We talk about how are those resources then accessible to users outside and inside our virtual network. We talk about those applications or pods inside that. And then we'll move on to deployment and automation related issues and considerations. So you can deploy the whole cluster using ARM templates. It doesn't matter as much. Usually the infrastructure as code pod that you're doing for Kubernetes is more about your service manifests and your Kubernetes infrastructure, not necessarily all of those bells and whistles that you configure on AKS. It's something that you can do, but a lot of times just storing your AKS creation scripts makes more sense as well. So instead of having in your pipeline the whole ARM template, you can just define the whole thing in Azure CLI scripts. What do you want? But you can define the whole thing on ARM templates. You can define your Kubernetes side also with tools like Helm. Helm is a great tool for creating these packages of Kubernetes service manifests and other configuration files. So instead of having those tons of YAML files, you have different types of YAML files that are creating those Kubernetes YAML files for you. And really any sort of secrets, if you still have them, if you're not moved all the way to managed identity and you really can't all the way with Kubernetes service yet, then you should be able to store those secrets in the Key Vault. You should be able to have a way of, when you're creating that infrastructure, identifying those resources, giving access to that Key Vault, and fetching, for example, your certificates and maybe changing your name server changes for your new Ingress controllers at runtime. And that's something that we struggled actually quite a lot of doing the pure play infrastructure as a service as code with one of my customers. Excuse me. And again, the Key Vault FlexVol is a good tool for, or good addition to your Azure Kubernetes service that you can use to automate that mounting of those keys, that identifying of who is actually fetching these keys, what are the access policies in the Kubernetes, what are the access policies in the Key Vault side, and so forth. And I quickly touch upon what about the certificates question. If everything that you build is defined in infrastructure as code, everything is, your actual applications are stored without state and without any secrets in some sort of container registry. If all your infrastructure, both the ARM and whatever you deploy in there, is actually stored or dynamically created, what about those certificates? At some point, maybe of the first initial pipeline, or at some point you need to have a way of inputting those certificates in your web application firewalls with your or with your any other Ingress controllers there. There are different ways, but at some point it's your purity or it's your idealisticness of your how much infrastructure as a code do you need? How often do you really need to rebuild the whole ARM template there? Because there is something called Azure Container Service Engine that you can use to rebuild the whole, everything that you do on AKS as it is and ship it around and move it anywhere that supports Kubernetes, essentially. It is a pain, but if vendor lock-in is something that you're really super afraid of, and if that's something that you can't have any downtime when you're shifting between cloud vendors, that's something that you need to look in, then you can't, for example, take into use of this. In Key Vault, we have a nice feature of automatically regenerating our keys. We can configure our Key Vault with the domain authority kind of buyer's credentials and get new certificates as we go. But again, if that's something that, if you're very much afraid of vendor lock-in, that's something that you can't really do. So you need to compromise on your puristicness of the infrastructure as code. So once you're deployed the whole thing, you can go ahead and check these built-in cluster built-in policies that we have available in essentially Security Center nowadays. All Security Center controls are and will be available in Azure policies, and they can actually now go not just to the resource provider level, but actually inside of the cluster as well. And all of the things that I talked about, enforcing those pod security policies, making sure your networks are okay, you're not exposing dashboards and that stuff like that. All of those policies are available automatically, visible to you if you just dare to look at your security center. It's always there, you don't have to turn it on. It's pretty nice. But if you want to do something repeatable, if you want to do something every build, if you want to have continuous assurance on your own and export all of that, you can look at Secure DevOps Kit for Azure, AZSK, which is a set of tools, essentially a line of PowerShell that you can run against your environment that actually goes ahead and checks a little bit more. This is just what fit in my screenshot. There's 20 or so different controls that Microsoft IT or Core Services Engineering is using actually to secure their own Kubernetes clusters as well. So there is a ton of things that I mentioned so far. So let's do a quick wrap up of those before we start thinking about where to get more resources and how do you move forward. And first of all, I really can't stress this point enough. The most important thing I want to highlight is that you really need to reboot your servers. The second most important point is really controlling the access to that list cluster admin credential resource provider action. You can do it with roles, you can do it with policies, but don't let your users skip your Azure AD authentication for your AKS. Just don't do that. Because yes, you want to authenticate using your Azure AD so that you can tie those known identities into two known roles, specific roles inside your Kubernetes role-based access control role mapping as well. You should control the incoming ingress traffic to your cluster, maybe in one centralized place. There's different options to spin up your own sets of pods. There's Nginx, there's WAF, there's tons of versions available, depends on what you want to do. Don't just use the built-in HTTP application routing ingress traffic. It doesn't support SSL. Microsoft says you shouldn't use it. It was just there for a while. They were just kidding. You were not supposed to use it. Again, store your secrets always at Key Vault, access them at runtime, and really Operational security is really the key, so you really should understand what you're doing when you're choosing to run your application in Kubernetes and building something new. You really should understand what is the amount of daily, nightly, weekly work that you need to put in there. And if it happens that you are actually building your second application already to the same cluster, then you really need to think about how are these pods and how are these nodes able to connect to each other through identity or network related controls. So let's talk about some takeaways. So compared to platform as a service, Azure Kubernetes Service allows us to be more secure. We have more options to do. We have more control in the spectrum of full-blown control, doing everything on our own, building our own systems on chips, building our own hard drives and whatnot, all the way to functions. AKS is somewhere close to infrastructure as a service. Pretty nice. A lot of control available, a lot of responsibilities that come from it. Of course, every application is different. Most likely, you will be able to use these controls that I talked about because they shouldn't require changes to your existing things. Regardless of your application that you have, you should be able to use most of these controls, but maybe not. Check the backlog. I have a link there. It's public backlog of everything that they have coming for the next 6 months or so. It's in GitHub. You can check, for example, limiting the dashboard, limiting the cluster masters IP address ranges, who is able to even run those kubectl, kubecontrol commands and all of that. That's in the backlog and so forth. Check those against your existing and maybe old enough security requirements to know what is something that you might expect AKS to support. You should use those automated tools. You should get a similar looking list of checks over time and see how your security is evolving, especially when you are having multi-vendor or multi-application team working with the same cluster. My slides will be available at Shirley Karl Slides. There's a ton of other materials over there. I also have a video course available for Azure Kubernetes. You can check it on O'Reilly, Safari, Udemy, or some other places. As also Martin mentioned, we have opened the global Azure registrations. There is one location in Finland already. Last year we had 3 in Finland. Now we have 1 in Helsinki already up. So if you're not from Finland, Espoo really doesn't count, then please go ahead to globalazure.net and sign up. We have 127 different locations right now signed up for this massive 3 days of Azure all around the world at the same time. That's coming up in the end of April. All right. With that, we are ready to prep for Rick. Thank you very much.